Hello, thanks for joining this session. My name is Vinay Shukla. I'm a Principal Product Manager at AWS focused on Amazon Redshift. Today, I'll review with you the Lakehouse approach to data warehousing and analytics with Amazon Redshift. Let's get started. So, to look at our agenda, we will start by looking at what is the Lakehouse architecture, what are the trends driving the Lakehouse architecture's adoption by our customers, what powers the Lakehouse architecture. We will look at some of the use cases that are made easier with this approach. And we will also look at new features of Amazon Redshift that make the Lakehouse approach even more powerful. Before we dig into the details of Lakehouse architecture, I want to start with a customer example. Yelp is one of key customers of Amazon Redshift, and Yelp chose the Lakehouse architecture. You may wonder, why did Yelp chose this architecture, and how is their analytic performing with this architecture? So Yelp chose this architecture because they have tens of petabytes of data, and they get data from their apps, from website at a very high, fast ingestion rate. All that data is generated and lands in a streaming fashion in their S3 based data lake where they have tens of petabytes of data. And a big fraction of that is also cleaned and ingested into Amazon Redshift, where their data warehouse has 500 plus terabytes of data, and they run their most SLA-driven SQL queries through Tableau and run them against data in Redshift. For the dark data exploration, Yelp also uses Athena, where their data scientists and data analysts use Athena for ad hoc and dark data exploration. Yelp also uses Redshift's ability to query the data in data lake, and since they use the Glue data catalog, the same table definition that was visible in Athena is also visible in Redshift, and they are able to query that their data lake while also joining that data lake with the data in Redshift. Yelp also used Materialized view, and with the Materialized view this year, when we provided the incremental refresh on Materialized view, Yelp saw tremendous benefit without running any manual maintenance themselves. So what you saw on previous slide with Yelp is the Lakehouse approach. And you may wonder, so what is the Lakehouse approach? In previous generation of data analytics, customers had their data warehouse, and when they reached the limit of data warehouse, they were not able to load all that data. With the advent of data lake, customers had the ability to store any amounts of data, and they were able to use the best fit analytic or big data system to analyze that data. But data warehouses still provided the best way to solve complex SQL problems, and customers found that they needed to use both Lakehouse, or rather data lake and data warehouse together. The Lakehouse approach combines the benefit of both of them, and from your data warehouse, you can query the data lake, and you can use the best fit analytic engine that your multiple personas want without any compromises. So this Lakehouse approach allows you to eliminate data silos. You keep one copy of data in your S3 based data lake, and you use Redshift to query the data in data lake, and you can also combine the data from your operational databases and use, as you will see further down the slides, machine learning and other analytic services. So when we talk to customers, we learn from them what are the trends that are driving the Lakehouse adoption for them. So customers see that their data will continue to grow. What they tell us, their data is doubling every year. So if data doubles every year, in next 10 years, that 1 petabyte of data will grow, 1 terabytes of data will grow to a petabyte in 10 years. So at this fast speed, the data warehouses approach will not scale as well, And that's where you need the lakehouse approach, because this approach will be able to keep up with the growth in data. As you saw in case with Yelp, and not just Yelp, we see the same trend from other customers, is that they are analyzing data as soon as it lands, and the pace of the data as it's landing in S3 is becoming faster and faster. And as a matter of fact, many customers want to run real-time analytics, and they want to analyze their data without loading it first. Customers also want to empower all their personas, not just data scientists or SQL experts, but ad hoc analysts, and want to enable everyone to use the best fit analytic engine without any compromise. With the growth in different analytic engines comes the growth in open data format. And customers want to use the best data format that is needed for their analytics service, at the same time not be locked into a vendor's proprietary format. Customers understand the downside of data silos, and they want to have a single source of truth and unified analytics. Customers tell us that their security team think that data should be easy to secure across their data lake, and they don't want to go from analytic engines to analytics engines to secure the same data in just different ways across different services and engines. So they want a unified security and governance approach, so they can secure the data once and use it across their data lake from multiple analytic services. In summary, these are the benefits of lakehouse approach. With lakehouse approach, you can eliminate the need to load any type of data. You can scale data. You can start small. You can have just a few gigabytes. You can scale to terabytes and exabyte, and you get the same low cost of S3 and reliability of S3. You can unify your security, compliance, and audit across the data lake by using lake formation, and you can have security from one place. You can also empower all your personas and use the best fit analytic service. As you will see in few slides down, you can also democratize machine learning and enable your SQL experts, who are typically the most familiar with the domain problem and domain expert, to use SQL to create and train machine learning model without any ETL required. And you can also unify your analytics across operational data warehouses and data lake. So what makes the lakehouse architecture possible? What powers the lakehouse architecture? As you saw, Redshift has an ability to query data lake. This ability is called Redshift Spectrum, and Redshift Spectrum is a serverless part of Redshift where you don't have to provision any infrastructure to make use of Spectrum. If you have a Redshift cluster, you already have Spectrum. With the Spectrum and the Redshift approach, you eliminate the need for loading data. Redshift is able to query data, whether the data is sitting in Redshift with the managed storage or Redshift cluster. And Redshift can at the same time query the data that is in S3, and Redshift can also join the data between the two. You can also use your familiar file formats that or open data formats such as Parquet, ORC, Avro, or JSON. You can scale to terabytes to exabyte. You pay for what you use, and Redshift Spectrum also integrates with the lake formation, so you have the same common catalog used across the data lake, regardless of whether you're using Redshift or not. The same external table definition is visible and used with Redshift that you use with Athena. So let's look at some of the use cases that are made easier and more powerful with the lakehouse approach. So not just from Yelp, we see that customers are enabling more use cases. They want to empower use cases such as fraud detection, streaming analytics, connected cars, to run, they want to empower their businesses to run these use cases. What these use cases have in common is that they are landing data from S3 into S3 from streaming sources as fast as data is being generated, which also means customers want to get insight and analyze that data as soon as it's landing without spending time on copy or ETL operation. With this approach, customers can use a streaming solution such as Kinesis or Kafka land data in S3, and as soon as the data is in S3, they are able to query it with Redshift via the Redshift spectrum. They can use any BI, ETL, BI tool of their choice, whether it is QuickSight or Tableau or Looker. As we saw on previous slide, customers want to enable all their personas, which also implies that customers want to use different analytic services, engines, and tools, such as, for example, for ad hoc analytics and querying dark data or data that is in S3, you don't need to set up any infrastructure. You can just go to serverless Athena and query when needed. For complex ETL, customers use Spark jobs running in EMR, and their data engineering team make use of EMR extensively. And their most complex and SQL customers, for most complex SQL customers use Amazon Redshift. Now, these are different analytic services, but with the Lakehouse approach, it's the same data that is in S3 with the same data catalog and same definition of external tables that can be queried across these different analytic services. So customers have a choice of the analytic system and analytic tools they use. They don't have to compromise, and they can use the best fit analytic services for their use cases and needs. Another use case we see from customers is the need to simplify their ETL and data pipeline. So traditionally, customers use ETL, which is stood for extract, transform, and load, which meant customers extracted data from their different sources, databases, such as operational databases. They extracted that data, put a copy of it in S3, then they ran some transformation, some ETL jobs such as EMR or other ETL jobs on that data. And then once the data is refined, they loaded that data into their data warehouse where it was ready to be queried by their data scientist and data analyst. With the other approach, which stands for extract, load, and transform, customers can extract their data from their data sources and run transformation after the data is already loaded into Redshift. And customers have a choice with this approach. They can run some transformations during the data as it's being loaded or into Redshift, or they can run transformations after the data is loaded into Redshift. And on this slide, you can see an example where during insert, the statement points to a SQL that refers to an external table sitting in S3. So this way, customers can select and choose what data to ingest and how to run transformation, and they have more flexibility into running those transformation because they can just use SQL that they use in rest of their analytic pipeline. Customers also, because they are using many different purpose-built databases, they have a need to combine the analytics across the data that's being generated from operational databases, from data lake, and their data warehouse into a unified query so that they can get insights by using data from all these sources. So until now, customers with this need had to extract data from different sources, ingest it, and copy it into Redshift before they can unify the analytics. Now with the federated query facility, customers don't have to run any expensive or time-consuming ETL. They can use Redshift's query federation, and Redshift will go out transparently to them and will push down the query fragments to different data sources, and that way customers get the benefit of unified queries without running any ETL or copy operations themselves. This simplifies their ETL and data ingestion pipelines. As you saw, customers, when they have a data lake approach, they also want a unified security and governance model across the data lake. And this approach allows customers to have their security administrator just use one console to define security and access control policy for all their data, regardless of which analytic engine or service they use. So for example, customers want to go to one place and say, here's my data security policy, and whether Athena or EMR or Redshift is used, the same security policy is applied because logically it is the same data that is in their data lake. So let's look at some of the new features that make the lakehouse approach and the use cases more powerful. As you saw, customers can unify their security with the lake formation based data catalog. Lake formation also has the fine-grained access control, so it can define security policy at a column level. With Redshift, we integrated into the lake formation's column level access control policy. So when you're using Redshift to query your external table that is reading data from S3 data lake, if you have your data administrator define the access control policy into the lake formation, Redshift, when the analyst comes in to query the data, Redshift will consult with the lake formation policy and allow you to have fine-grained column-level access control. Many customers tell us that they use these different analytic services together, and often there is a need to share data between between multiple analytic services. Especially customers who are using Redshift, they have their most curated data in Redshift, and if they need to share that data with EMR or Athena, they have a few choices. They can export the data through the unload command, and which can unload the result of a SQL query and put that data in S3. There is also a create external table as command available with Redshift, where the result of a SQL query can automatically be created as a glue catalog table as an external table, and customers using Athena or EMR are able to query that table right away. Another new feature of Redshift, which is a performance enhancement and customers don't need to configure anything, is Bloom filters. Bloom filters are a probabilistic data structure, and basically this data structure checks whether a given element is present in a set or not. And Redshift uses the Bloom filter to reduce the data it scans from S3, and that's how many of the queries we tested on TPCDS are 10% faster, and some queries are up to 2x faster. As I mentioned previously, with Redshift Spectrum, there is no infrastructure to provision. The same is also true for Redshift concurrency scaling, which allows you to spin additional compute cluster to serve thousands of users and queries without on a spiky workload. With both concurrency scaling and Redshift Spectrum, we have thousands of our customers using these features, and one feedback we heard from them, while they like that they don't have to provision any infrastructure to support concurrency scaling or to use concurrency scaling or Spectrum, they also wanted more control over their cost. And based on their feedback, we implemented cost control on concurrency scaling and Redshift Spectrum. With this, as an administrator, you can go and set daily, weekly, or monthly limit on the spend. And you also have a choice of what actions to take if the spend is reached. You can set alerts, or you can log the event, or you can actually disable the feature as well. And this gives you more control over your cost for pay-per-use that you get with concurrency scaling and Redshift Spectrum. Next, I wanted to share with you another new feature of Redshift. That's the ability to read Apache Hudi and Delta Lake tables. So both Apache Hudi and Delta Lake tables read data that is sitting in open data format staying in Amazon S3. And customers use Apache Hudi and Delta Lake so that they can implement use cases such as change data capture or GDPR and have their data lake be ready for modification. Now, customers can use EMR to write Apache Hudi data, and the same data is registered as an external table. And using Redshift, they are able to query the data as it's changing in Amazon S3 data lake. So this allows customers to implement transactions across their data lake and implement new use cases such as change data capture and GDPR. So we talked a little bit about federated query. When we launched federated query last year, it supported Postgres for both RDS and Aurora. And recently, we have also enhanced the federated query to support MySQL for both RDS and Aurora. Now, your ability to federate query is even enhanced since you can query not just Postgres, but MySQL databases. Redshift offers materialized views, and materialized views are a performance enhancement. So if you have very complex SQL that does a lot of joins across multiple tables and aggregation, you can pre-compute the result, and Redshift will store the result in its own storage. Now, the materialized view support is also available whether the data is in Redshift or if the data is stored in S3 as an external table. So we have extended the materialized views to be able to query to be able to materialize the result of a query on external table. So this feature offers you even faster performance for your data in S3. Another feature of Redshift that we are super excited about that's in preview that we think a lot of customers will like is Redshift ML. As more and more customers have use cases like product recommendation, fraud prevention, identifying churning customers, they want to not only allow their data scientists who use analytic services such as SageMaker, but also want to enable their SQL expert, who are typically also domain expert, to be able to create, train, and apply machine learning models. Now they can with just using SQL. So in this slide, you can see an example of a SQL command that creates a machine learning model, and transparently to them, Redshift will integrate with SageMaker, send the model to train on SageMaker, and get the model back and deploy it in with Redshift so customers can run inference or predictions on those models, again from SQL, just using a familiar UDF-based approach to get results of those inferences into their SQL statement. So this makes customers SQL experts also machine learning experts, since they are able to create and deploy and use machine learning model from SQL. So in summary, the benefits of Lakehouse approach is that you eliminate any data loading. You can scale from any size. You can start with just gigabytes of data, and you can go to terabytes and exabytes of data with low predictable cost. You can get a unified security and compliance and audit capability across your entire data lake. You can empower all your personas, use the best fit analytic engine of their choice. You also get to democratize machine learning with SQL, so you can enable more of your SQL experts to create and train machine learning model. And you can also unify analytics across operational, data warehouse, and data lake. After this summary, if you are super excited about Redshift, I encourage you, and if you are not yet an existing customer of Redshift, if you're not using Redshift, I encourage you to go to Redshift website and create a demo and play with getting started. You can also ask your account team to give you a demo. If you are a new Redshift customer, I'm sure you saw a lot of new exciting announcements from Redshift, and you can track all those announcements and learn more in the What's New page of Redshift. With that, I thank you for attending and joining this session. And please take this survey, give me feedback, and help me get better. Thank you.